So I had written a lot of this stuff out. The video that I had recorded while I was writing this out was somehow lost in translation between my computer, or the camera, and my computer before uploading it. Just so without having to redo everything, I wanted to draw on the fact that these components for the weight, the component along the coordinate that is perpendicular to the surface of the ramp and that which is parallel to the surface of the ramp, are simply coordinates of this weight, and those can be calculated by using the angle theta here, which is the exact same angle that the ramp is raised at. So we can draw the similar, because these are similar triangles, we can determine that the weight here, the weight in the y prime direction, is equal to the mass times gravity times cosine of theta, simply because the weight here is the hypotenuse and the adjacent side would be the weight in the y direction. Similarly, the weight along the x prime direction is mg times sine theta. We can make sure, we can check in that, well, what in the case for the limiting case that theta is very, very small, as that goes to 0, the weight along the y prime direction will eventually just be equal to mass times gravity. And so when theta is very, very small, cosine of theta, so as this theta goes to 0, cosine of theta goes to 1, and the weight in the y prime direction is simply equal to mass times gravity. Similarly, as if our ramp were to get very, very steep, we could also see that the majority of the weight would be along the direction that is parallel to the ramp, and so we would see in that case the weight along x prime becoming very, very large. As theta approaches 90 degrees, or pi over 2, sine of that value would be close to 1, where most of our weight would be, most of the weight along the direction, or most of the force along a direction which is parallel to the ramp, would be equivalent to the weight that the object experiences due to the gravitational force of Earth. That tells us then that this gives us the force that causes acceleration of the motion of the block, and also the weight that is along a direction that is vertically, that is perpendicular to the surface of the ramp. That tells us what our normal force would be. And this is when we talked about, this is a little bit of what we talked about in class on Monday, the fact that Newton's third law pair is something where the normal force is the ramp pushing on the block, and that normal force isn't equal to the actual weight of the object. It's only equal to this component that is along the y direction, a y prime direction. And you can probably hear my youngest child crying in the background, so I'm going to have to go check on him in just a second. But to finish this up, so this normal force is going to be equal to mass times gravity times the cosine of the angle theta. And so as you can tell, cosine of theta goes from 0 to 1 depending on the angle of this ramp, and so the normal force for an object on a ramp of this type is always going to be less than that of the actual weight, the mass times the gravity. Okay? So I said some other things in the other video. This should be helpful in helping to answer the question for your homework dealing with the ramp that's accelerating. But I'm going to, hopefully this is helpful in getting that far, and hope you guys can get the rest of the way.